We detect some fast-moving thing in the solar system with hyperbolic speeds headed towards Earth, and then it rapidly begins to slow down. Oumuamua is the first visitor from interstellar space that we have ever confirmed moved through our solar system.
Out past Pluto, in the cold silence of deep space, something's on the move. A lone speck of light is drifting in from the interstellar dark, and it's definitely not from around here. Astronomers have just confirmed it. We've got a brand new visitor from another star system, only the third one ever spotted since the legendary Oumuamua shocked the world back in 2017. In mid-2025, a powerful telescope in Chile picked up the strange signal, an object gliding in on a bizarre path that didn't match any known space rock in our neighborhood. At first, it was just a tiny blip in the ATLAS, Asteroid Terrestrial Impact Last Alert System survey, which scans the heavens for anything suspicious. But this blip was different, and it got scientists buzzing. Was it a comet? An asteroid? And why was its path so off? On July 1, 2025, the Atlas Survey Telescope in Rio Hurtado, Chile, first caught sight of it. The odd traveler was given the cryptic tag A/2025 L3Z, but within hours, its unusual orbit set off alarms in the astronomy world. This thing wasn't from our solar system at all. By the very next day, the International Astronomical Union made it official. This was an interstellar object, now named 3I/ATLAS, I for interstellar. Picture it. A frozen alien chunk of rock and ice launched from a distant star, now casually cruising through our cosmic backyard. For astronomers, it was a pure eureka moment. For everyone else, it raised a chilling thought. Should we be worried about this alien comet? The answer: relax. From day one, scientists confirmed 3I/ATLAS poses no danger. Its closest approach will keep it over 150 million miles away, about 1.6 times the distance from Earth to the Sun. This cosmic drifter won't even cross inside Mars' orbit, so no crash, no doomsday, just a once-in-a-lifetime chance to study something truly alien. Larry Dino, one of the minds behind the ATLAS project, admitted, "We don't know very much about this object." For scientists, those words are both humbling and electrifying, because it means we're staring at something brand new. Here's what's certain: 3I/ATLAS could be up to 12 miles wide, a massive frozen space iceberg. When it was first detected, it was a staggering 4.5 astronomical units from the Sun, about 4.5 times farther than Earth. And even from that distance, it was already tearing through space at an insane 40 miles per second. That's over 140,000 miles per hour relative to the Sun. No comet born in our solar system can reach that kind of speed naturally. This one was definitely kicked out from somewhere far, far away. The Minor Planet Center quickly made it official. This was no ordinary rock. They reported hints of comet-like activity, a faint coma, and a tiny 3 arcsecond tail. Translation: 3I/ATLAS is waking up. Its frozen gases are heating under the Sun's light, transforming straight into vapor, creating a glowing halo of dust and gas and leaving a delicate trail behind. It's the first sign this isn't just dead space debris. It's alive with motion and chemistry. And here's the wild part. All this was spotted while it was still ridiculously far and incredibly faint, around 18th magnitude, invisible without a serious telescope. The fact we even caught it proves just how far modern astronomy has evolved. Once Atlas flagged it, observatories in Hawaii and Australia locked on, tracking its course together in a global effort to follow this mysterious wanderer. Amateur astronomers jumped into the hunt, digging through old sky survey images, and bingo! They found hidden shots of the object buried in data from mid-June 2025. These early clues sharpened its trajectory and confirmed what the pros suspected. This was no local rock. By July 2025, the verdict was official. An interstellar comet was on its way. only the third ever seen by human eyes. Naturally, the big question came next. How does this cosmic wanderer stack up against the other two? Let's rewind. The first was spotted in late 2017 and given the Hawaiian name Oumuamua, meaning scout or messenger from afar. The second, in 2019, was 2I/Borisov, named after the amateur who discovered it. The two couldn't have been more different. And now 3I/ATLAS is here to throw in a brand new twist. Oumuamua was a complete enigma, a skinny, cigar-shaped object about 100 yards long with no visible coma or tail. As it drifted away, it even picked up a strange non-gravitational acceleration, veering slightly off its expected path. Some said it was just gas escaping from its surface. Others whispered about something more exotic. Either way, Oumuamua vanished, leaving more mystery than answers. Borisov, on the other hand, felt familiar. When it cruised in back in 2019, it looked and acted like a classic comet from our own solar system. Bright gas coma? Check. Long dust tail? Check. Its composition, revealed by spectroscopy, was a mix of water vapor and carbon-based molecules, exactly what you'd expect. If not for its hyperbolic orbit, you could have sworn it was born right here. Now, the spotlight's on 3I/ATLAS. The burning question, will it behave like the eerie, silent Oumuamua, or the blazing textbook comet Borisov? The answer could tell us just how wild and varied interstellar visitors really are. Early signs point to 3I/ATLAS being more like Borisov than Oumuamua. It's faint, fast, but already sporting that classic fuzzy coma. A dead giveaway that ice is evaporating into gas. That makes it far more likely to be an icy, comet-like body than a dense, rocky shard. And just to clear the air? No, there's zero evidence it's an alien craft. What we've got is a fascinating natural visitor from another star system. But here's the jaw-dropper, its size. Based on its brightness at discovery, astronomers believe 3I/ATLAS could be 9 to 12 miles across, making it bigger than both Oumuamua and Borisov combined. For context, Borisov was only about 0.6 to 1.2 miles wide, and Oumuamua was a tiny sliver by comparison. If these numbers hold, Atlas could pack way more mass, meaning more material to study as it outgasses and sheds its ancient layers into space. Then there's its trajectory. Oumuamua swooped in from the plane of the solar system, roughly from the direction of the star Vega. Borisov came in from a totally different part of the sky, toward Cassiopeia. But Atlas? It's barreling in from Sagittarius, aimed roughly from the galactic center region. Physicist Marshall Eubanks, who's been tracking the object, says ATLAS most likely came from the thin disk of the Milky Way, the same flattened plane where most stars, including our Sun, orbit the galactic center. That means it probably formed around a star somewhere inside that sprawling spiral of the galaxy. Pinning down exactly which star is another story. To do that, we'd have to trace the comet's path backward across millions of years, all while accounting for the galaxy's constant gravitational shuffle. And right now, that's simply impossible with the data we have. The fact that 3I/ATLAS likely came from the inner galaxy hints that its makeup might be similar to comets we know from our own neighborhood. But here's something every interstellar visitor, no matter how weird or unique, has in common. They're not tied to the sun. These objects all follow open-ended hyperbolic orbits. They swing in once, loop around the sun, and then vanish back into interstellar space, never to return. It was this exact hyperbolic path that outed Atlas as an outsider. The calculations were clear. Its orbital eccentricity was about 6, way beyond the limit of one that defines a bound orbit. Translation? This thing isn't a solar system native, it came from beyond. And that begs the question, what kind of cosmic journey brought it here? Maybe it once circled a distant star like a loyal comet, orbiting peacefully for millions of years. Then, A close pass with a massive planet in that alien system slingshotted it into the black void. From there, it drifted through the silent gulf between stars for eons, until fate nudged it into our sun's path. We'll probably never know the full story, but as the third interstellar object in history, Atlas is too valuable to ignore. Astronomers everywhere are watching it like hawks, trying to squeeze every bit of data out of its brief visit. As of mid-2025, Atlas is closing in. Fast. Its orbit? Extremely hyperbolic, confirming it's a one-time guest. After it sweeps past the sun, it's gone forever, headed back into the galaxy's deep freeze. Calculations predict it will hit perihelion, its closest approach to the sun, at the end of October 2025. Whatever secrets it's hiding, we've only got one shot to catch them before it disappears into the dark. Atlas will reach perihelion, its closest approach to the sun, at about 1.4 astronomical units, roughly 130 million miles, putting it just inside Mars's orbit. On the way in, it'll even pass relatively close to the red planet this October, coming within 0.4 astronomical units, about 37 million miles. That's not a near miss, but it's close enough that Mars-orbiting spacecraft might actually spot it. NASA's Mars Reconnaissance Orbiter could snap an image as it zips by, and scientists are already crunching the numbers to see if cameras on or near Mars can capture the moment. Even far from the Sun, ATLAS is a speed demon. Its velocity relative to the Sun was already about 37 miles per second, and it's still accelerating under our star's pull. By the time it hits perihelion, it's expected to blaze past at over 150,000 miles per hour, roughly twice Earth's orbital speed. After it slingshots around the Sun, it will have so much momentum that it'll break free of the Sun's gravity entirely. And it won't just coast away. By April 2026, when it's outbound again, its speed relative to Earth could hit 55 miles per second. That would make it a record setter, one of the fastest natural objects ever recorded in our solar system. The best part? It's not just a rock on turbo mode. ATLAS is officially classified as an active comet. Those early whispers about a faint coma and tiny tail? They've now been confirmed. As it sweeps through the outer solar system, sunlight is warming its surface, turning ice directly into gas and creating that glowing halo and dusty trail. In other words, this alien traveler is very much alive with activity as it speeds toward its fleeting date with the Sun. As Atlas heats up, sublimation kicks in. Ice turns straight into vapor, spewing gas and dust into space. This creates a hazy coma around its core and a delicate tail stretching behind, shaped and pushed by the solar wind and sunlight. As of mid-2025, that coma is still weak, and the comet sits at around 18th magnitude, far too faint for the naked eye. But big amateur telescopes are already catching it, and with sensitive CCD cameras and long exposures, it appears as a faint smudge sliding across the star field. Each week, more ice boils away and the comet inches closer, making it brighter. By August or September 2025, Atlas could hit 15th or 16th magnitude, maybe even a bit brighter. Still invisible without a telescope. For comparison, the faintest stars visible in a perfectly dark sky are around 6th magnitude, but within reach for skilled amateur astronomers, armed with good optics and high-quality cameras. Nick James of the British Astronomical Association predicts ATLAS should remain in range for amateur gear for roughly a year. But here's the catch. Comets are notoriously unpredictable. And since 3I/ATLAS was born around another star, there's no guarantee it will play by our rules. It could surprise us with a sudden outburst of brightness, or fade faster than expected if a crusty outer shell chokes off its gas release. And that leads to the burning question: what is this alien visitor made of? The answer lies in its light. If scientists can capture spectra of the coma, splitting the light into its rainbow of wavelengths, they can read the chemical fingerprints and compare them to comets from our own solar system. When 2I/Borisov was studied, it revealed familiar gases like cyanide, diatomic carbon, and water vapor, but also a huge dose of carbon monoxide, hinting it came from a much colder stellar system. Atlas could hold similar surprises, or something we've never seen before. Early signs say 3I/ATLAS isn't a rocky shard at all. It's mostly ice, as proven by that hazy coma already forming around it. As it closes in on the sun, the heating will kick its sublimation into overdrive, and that's when telescopes will pounce. Scientists will be hunting for telltale gases, water vapor, carbon-based molecules, maybe even oxygen or complex organic compounds. Think of it as cracking open a lab sample from another star's pantry. Whatever shows up, or doesn't, will be huge. If Atlas matches the chemistry of our own comets, it would suggest the building blocks of planets, and maybe even life, are universal across the galaxy. But if it's chemically different, that's just as exciting. It would mean it was born in a place with a completely different recipe for worlds. So, why all the hype over a comet that most people will never see? Because 3I/ATLAS is a physical piece of another star system, and it's dropping by our neighborhood for free. In all of human history, every sample we've studied, moon rocks, Martian meteorites, comet dust, asteroid fragments, came from within our solar system. This is different. Interstellar visitors give us a chance to study alien chemistry without sending a probe on a mission that would take tens of thousands of years with today's technology. Atlas is a messenger from afar, carrying secrets about the birth of planets, maybe even the origins of life in distant corners of the universe. Somewhere in its makeup could be clues, strange isotope ratios, rare molecules, or other cosmic fingerprints that reveal exactly where and how it formed. And for the first time, we're here to catch one in action. At the heart of it all, it's about curiosity and pure science. Every interstellar object is unique, and with only 2 confirmed before this, each new arrival can completely reshape what we know. Is 3I/ATLAS a one-off oddball or part of a larger pattern? If its chemistry ends up mirroring Borisov's, maybe most star systems out there make comets just like ours. But if it's wildly different, we could be looking at something forged in a far stranger environment. And here's the exciting part. With 3 confirmed samples, we can finally start estimating how common these alien visitors really are. Some researchers think thousands could be drifting through our solar system right now, most too faint to notice. As telescope technology improves, we might start spotting them regularly. We're standing at the start of a new age of discovery. The Vera C. Rubin Observatory in Chile, now operational, will scan the heavens every night with unmatched sensitivity. Experts predict it could detect several more interstellar objects within the next decade. That means Atlas may be the first in a whole wave of cosmic visitors we'll get to study. And this isn't just academic, it's preparation. Space agencies like NASA and ESA are eyeing these objects not only for the science, but for the challenge they present. They're fast, unpredictable, and often spotted with little warning. One day, if an interstellar traveler's trajectory puts it on a collision path with Earth, we'll need to know how these things behave, and whether they're a threat or an opportunity. That's why missions are already on the drawing board to visit or intercept them in flight. Imagine a spacecraft racing to meet an alien comet head-on, catching it before it disappears forever into the void. With ATLAS, we're not just watching history, we're getting ready for the future. One mission already in the works is ESA's Comet Interceptor, set to launch in 2029. It'll park in space, lying in wait for the perfect target, maybe a pristine Oort cloud comet, or if we're lucky, another interstellar visitor. The beauty of this plan? No scrambling, no starting from scratch. The probe will be ready to blast toward whatever appears, racing to meet it in deep space. If we had something like that right now, imagine the science hall from flying past 3I/ATLAS, sampling its dust, sniffing its gases, capturing close-up images of a true alien comet. The tech to do that is coming, but not fast enough for this round. Atlas was found only months before its closest approach, far too late to plan a chase. It'll vanish back into the dark almost as suddenly as it arrived. Still, the knowledge we gain now will shape future missions. Next time, we might spot an interstellar traveler years before its flyby, giving us the time to prepare for a full-on rendezvous. And that matters, because even our fastest rockets would need tens of thousands of years to reach the nearest stars. An object like this? It brings a piece of another star system to us. That's a gift we can't ignore. So should we be afraid of ATLAS? Absolutely not. We should be in awe. It's proof the universe is open. Matter, and maybe even the seeds of life, can drift from star to star. Right now, telescopes worldwide, from massive observatories to backyard setups, are locked on it. Astronomers are tracking its brightness, watching its tail unfurl, and fine-tuning its orbit. From now until September 2025, it'll be perfectly placed for nighttime viewing from Earth. After that, it'll swing toward its October rendezvous with the Sun, and then disappear forever into the black. Don't blink. This is history in motion. By late October 2025, 3I/ATLAS will swing into perihelion, lining up almost directly with the Sun from Earth's perspective, which means it'll vanish in the glare, hidden in daylight. But come early December 2025, as it races back out of the solar system, it'll reappear in our skies for one last fleeting look before disappearing forever into the dark. Opportunities like this don't come often. It could be decades before another interstellar traveler crosses our path. This visitor from another star will be gone in a flash, but the knowledge it leaves behind will last forever, inching us closer to understanding our place in a galaxy full of wanderers. If you enjoyed this journey into the story of 3I/ATLAS, make sure to like this video, share it, drop your thoughts in the comments, and subscribe so you never miss the next cosmic mystery we uncover. The universe is speaking. Let's keep listening.